Hi everyone, welcome back to Math with Amala. Let's start a new part of your chapter. Number 10 of grade 8 exponents and powers. Let's take the exponent example 10 raised to 24 and it is normally called like 10 raised to the power 24. Here the power is 24 and 10 is the base. Powers with negative exponents. As the exponent decreases by 1, the value becomes 1/10 of the previous value. Let's take 10 square. This is 10 into 10, that is 100. 10 raised to 1 is 10 into 1, that is 100 by 10. 10 raised to 0 is 1, which is equal to 10 by 10. As the power decreases to 10 raised to minus 1, it is 1 by 10. The 10 will be moving to the denominator. 10 raised to minus 2 is equal to 1 by 10 divided by 10, that is 1 by 10 square. So the note is, for any non-zero integer a raised to minus m is equal to 1 by a raised to m, where m is a positive integer, a raised to minus m is the multiplicative inverse of a raised to m and vice versa. Likewise, the vice versa implies a raised to m is the multiplicative inverse of a raised to minus m. Let's find the multiplicative inverses of the following. 2 raised to minus 4 will have the multiplicative inverse 2 raised to 4. Likewise, 5 raised to minus 3 will have 5 raised to 3. Expansion. 1045.36 can be expanded like this. 1 into 10 cube, 0 into 10 square, plus 4 into 10 raised to 1, 5 plus 5 into 10 raised to 0, plus 3 into 10 raised to minus 1, plus 6 into 10 raised to minus 2. Here positive and negative exponent expansions are given in a table. According to the power of 10, the value will be moving towards right or left. 1 is 10 raised to 0, which is the middlemost one. Then 10 raised to 1 is 10. 10 square is 100. 10 cube is 1000. Likewise, 10 raised to minus 1 is 1 by 10. 10 raised to minus 2 is 1 by 100. 10 raised to minus 3 is 1 by 1000. Here we can relate this 10 raised to minus 1 as the next point of decimal. 10 raised to minus 2 as the second next point of decimal. Likewise, you can continue. Laws of exponents. There are some laws, up to 5 laws are there, 6 laws are there, and they are a raised to m into a raised to n is equal to a raised to m plus n, a raised to m by a raised to n is equal to a raised to m minus n. We have discussed all the things already in our previous classes, and you can reach at a raised to 0 equal to 1. There is a note. These laws are applicable to both positive and negative powers. Yes, here in the previous class we were discussing only about the positive powers, and now you can apply both on negative powers also. Exercise 10.1. 3 raised to minus 2 can be written like 1 by 3 square, that is 1 by 9. Minus 4 raised to minus 2 is equal to 1 by minus 4 raised to 2, because a raised to minus m is equal to 1 by a raised to m. Likewise, 1 by 2 whole raised to minus 5 can be continued. And let's concentrate on the problem. 3 raised to minus 1 plus 4 raised to minus 1 plus 5 raised to minus 1 whole raised to 0. This is, of course, anything raised to 0 is 1. In order to evaluate the 1 by 3 whole raised to minus 1 minus 1 by 4 whole raised to minus 1, you have to convert it with the laws of exponents. Then the answer is 1 by 3 raised to minus 1 minus 1 by 4 raised to minus 1 whole raised to minus 1, that is 3 minus 4 whole raised to minus 1 minus 1 raised to minus 1, the answer is minus 1. Now you can move to the 7th question also. Next one, use of exponents to express small numbers in standard form. For example, the average diameter of RBC, that means the red blood cells, is 0.00007 millimeter. You can express this in another form of this standard form. For that, you have to write 7 first, which is the only single digit in it. Write it first, then into 10 raised to minus 6. That means how many zeros are there, or how many positions are there after dot, after decimal. You have to raise it towards the power. 0.0016 equal to 16 by 10,000, which is equal to 16 into 10 raised to minus 4. So your answer 1.6. Why it is 1.6? You have to fix 1 or a single digit and at the beginning, then 1 point, and then you can write the remaining numbers into 10 raised to minus 3. In the standard form, count the total number of places after decimal, put the very first single number, put decimal, and then into 10 raised to minus x, where x and number of remaining digits will give the total number of places after the decimal. like we have discussed for the previous question. 0.000001 is equal to 1 into 10 raised to minus 6. There are 6 places after decimal, so it is 1 into 10 raised to minus 6. In 0.07, there are 2 places after decimal, so you can write 7 into 10 raised to minus 2. Now let's compare very large and very small numbers together. And that means we are converting it to the usual form or the expanded form. Expanded form is in the form 0.000754 and the standard form is 7.54 into 10 raised to minus 4. To convert to expanded form, count the negative power along with places after decimal. Put spaces accordingly, and after decimal starting from right to left, write the whole digits and fill the places with 0 if needed. This is the same procedure that we have done for the previous question. 3 into 10 raised to minus 5. That means there are 5 places. Give 5 places and put the number which is given at the last position, or fill it with the last. Then 0.00003. Fill the remaining places with the 0. In 3.52 into 10 raised to 5, you can give that much of decimal places over there. Then you can fill it with 352 and move towards the right. Because it is not negative 5, it is positive 5. For positive powers, move from left to right and fill that much zeros after digits. Okay, so this is the second case. Keep practicing and don't forget to follow this channel for more updates. Thank you all for watching the video. Please be stay tuned for the upcoming parts of your classes.